Today, we're doing a deep dive into a really specific piece of emergency technology. We're looking at the NTI E-AVDS-4G1-P. It's a 4G automatic voice dialer. And our mission, really, is to unpack what a device like this tells us about, staying connected when all the conventional stuff is gone.
Right, and what's so fascinating here is that this product solves that exact problem, the absence of infrastructure. You might have a critical piece of equipment, maybe a pump station or a server rack, just miles from any kind of landline.
And so what do you do?
Well, this is it. The sources make it really clear. They call it, and I'm quoting, ideal for remote places without conventional phone lines.
So it's pure redundancy.
Exactly. Redundancy distilled right into a single small box.
Okay, so let's break that down. How does it actually work in practice?
Well, it's what you'd call an event-driven system. It's not, constantly reporting back or anything.
It's passive.
It is. It just sits there and waits for a connected sensor monitoring temperature, humidity, whatever you've got to cross a threshold that you've already set.
And that's when the clock starts ticking.
That's when it wakes up. And when that trigger happens, the response is immediate. It starts calling or sending SMS messages
So how many people?
to up to 8 different telephone or cell phone numbers.
8. Okay, that's pretty robust.
It is, but there's a prerequisite. You have to supply your own mini SIM card that can handle SMS.
Right. It needs its own cellular backbone, which you provide.
Exactly.
Okay, and this brings me to the part I find really interesting. The constraints on that communication. You get one voice message right, and it's only 20 seconds long.
20 seconds max. Yeah.
Or if it's a text, it's just 70 bytes. I mean, that's barely more than a tweet used to be. Why so brief?
I think it's absolutely a design choice. It's philosophical.
How so?
Well, think about it. When a critical system fails, you don't need a long story. You need to know 2 things.
What failed and where?
Precisely. 70 bytes is just enough for something like System 3 Critical Failure 14.0. It forces you to be clear. The goal isn't a conversation.
It's a guaranteed lightning-fast alert. But if we're relying completely on 4G, aren't we just swapping one dependency for another? I mean, what if the cell tower goes down?
That's a critical question. And to mitigate that, the device supports the key 4G LTE and 3G WCDMA bands.
So it can hunt for the best available signal.
Right. It maximizes the chance of getting a signal out.
Well,
It also interfaces directly with other NTI gear through its output relays and runs on a standard 12-volt power supply, so it's easy to integrate.
and looking at the specs, it's clearly built to be put in some pretty harsh places.
Oh, absolutely. The operating temperature range it's quite wide. We're talking 39 to 140 degrees Fahrenheit.
So that's about 4 to 60 degrees Celsius.
It is, and it's a compact little unit. It means you can stick it in a remote utility cabinet or some industrial control room and not worry about it. It doesn't need its own air conditioning.
I also saw it's TAA compliant. That feels significant.
It is. That means it meets U.S. government procurement standards, which suggests it's reliable enough for, critical, maybe even federally funded applications.
Okay, so there's a certain level of trust built into the hardware itself.
For sure. And the commercial details seem to back that up. You've got the part number, E-AVDS-4G1-P, a price right around $250.
And it comes with a 2-year warranty.
A 2-year warranty and even a 15-day trial. They're clearly confident in this thing.
So if we kind of pull all this together, what's the big takeaway here?
I think this device is a specialized bridge. It ensures you can monitor things reliably by just completely bypassing that dependence on physical lines.
And it shows that this kind of focused cellular connectivity isn't just a backup anymore.
Not at all. For these geographically isolated assets, it's increasingly the most dependable primary security layer. It really proves that the quality of your alert trumps the quantity of your data.
That makes perfect sense.
Which leaves a pretty interesting question for you to think about. If you had only 70 bytes, no more, no less, to convey a critical system failure, what is the single most essential piece of information you would choose to send?
That's a great thought to end on. What's the one crucial signal you need to get through all the noise?